Hey guys, this is Mr. Lowry. I wanted to give you a little bit of homework help on this section here, 5.4. You're going to have a homework assignment out of this section. So I want to get you started on that. I'll kind of show you what problems you're going to be doing and then give you a couple more examples. So let's get started here. The first idea that's actually probably the main idea of this section here is that some systems of linear equations don't have one solution. Okay? We've been talking about systems of linear equations and finding their solutions, and we know that the solution to a system of linear equations is the intersection point, right? So if you graph two lines and you found their intersection point, that would be the solution for a system, okay? Now we have other ways of finding that intersection point, algebra ways, right? We have elimination, we have substitution. But graphically, we know that the solution to a system of linear equations is an intersection point, okay? What we haven't really considered yet is what if those lines are parallel? In other words, what if there's no intersection point, right? That could happen. So we could have two equations that are parallel, the lines are parallel, and they never intersect, which means we're going to get no solution. Okay. Another option is if we have infinitely many solutions, and that's kind of hard to see here, but basically imagine you draw a line, right? And then your second equation is actually right on top of that other line. So you can't, it's hard to see that here, but imagine that there's two lines here, and they're both blue, and one's on top of the other. Or in other words, the lines are the same. If there's one line on top of another line, how many intersection points are there? Well, every single point on the line becomes an intersection point because the two lines are touching everywhere. Okay, so these are the different options you could have when you have a system of two linear equations. You could have intersecting lines that have a solution, a single intersection point. You could have parallel lines that never intersect and you have no solution. Or the two equations could actually be equations for the same line, in which case you have infinitely many solutions. Okay, so let's take a look at a few example problems from your homework. So in your homework, you're going to be starting on page 239, and you're going to start with number 9. Okay, so there's a problem set that goes 9, 10, 11, 12, and then there's the same instructions up here for 13, 14, 15, and 16. Okay, and the idea here is that you're just going to solve the system, but we got to keep in mind that sometimes we're going to have systems that don't have any solutions. So we could potentially get no solutions, or we could get infinitely many solutions. Okay, so let's take a look at a couple of those problems. Let's start with number 10, okay, right here. So I'm going to write it down real quick and then show you what we're going to do here. So we got y equals negative 6x minus 8, and then we got y equals negative 6x plus 8. Okay, move the book really quick. All right, now there's multiple ways of solving this. We could solve it by graphing, we could solve it with substitution, we could solve it with elimination. It doesn't really matter, but I think this one is, the best way to solve this one is probably substitution. So notice they're both in slope-intercept form, okay, y and y. When that's the case, what I can do is I can just replace this y with what y is equal to, right? So I can say negative 6x minus 8 is equal to negative 6x plus 8. Okay, so I'm basically setting this equal to this because they're both equal to y. So if y equals this and y equals this, then this has to equal this. Okay, so I start with setting up this expression, and we're just going to kind of use algebra to solve. Okay, the first order of business here is to group the x's, get all the x's together. Okay, got some x's over here, got some x's over here. So it doesn't really matter what side we put them on. Let's group them to the left. So I'm going to add 6x here so that that goes away, and I'm going to do the same thing on both sides. Okay, what happens here then is that it actually cancels in both places, and I get negative 8 equals 8. Well, that's kind of weird, right? All the x's went away. We've actually seen this before when we were we solve equations, and sometimes we get what's called a contradiction, right? This type of statement, an untrue statement that's never going to be true, doesn't have any x's at all, we call this guy a contradiction. Okay? And so what we say is that there's no solution here. Okay. So sometimes in the process of solving a system, you get a contradiction because the lines never intersect. Okay. Now let's just take a closer look. Let's go back here and actually, kind of take a look at these really quick. Notice that these equations are both in slope-intercept form, and this is the slope, right? Slope-intercept form is y equals mx plus b, and m is the slope. It's the number multiplying x. So these two guys have the same slope, but they have different y-intercepts. Well, if you think about it for a second, equations that have the same slope become parallel lines, right? Same slope but different y-intercepts. These are actually going to be parallel lines. So you can kind of tell even before you start that you're going to have no solution because the slopes are the same but the y-intercepts are different. We'll talk about that a little bit more in the next section, but I just kind of wanted to give you a heads up with that. Okay, let's pick another one and go from there. See what's going on. Let's pick a harder one. Let's do 15. Sorry, let's do 16. All right, so in 16, we have 3x minus 2y equals negative 5. We got 4x plus 5y equals 47. Okay, so we have to pick a method. That's the first thing. Now up here, we did substitution, right? We tried to solve this guy by substitution. We replaced this variable y with this stuff. So that's a substitution. Now here, notice that these are both in standard form. We have the x's and then the y's and then the numbers. So they're kind of stacked, ready to go for elimination. So I would probably use elimination here. Whereas up here, we use substitution. Okay, and you can kind of pick your method. You don't have to use any particular method. You just kind of choose what the problem is set up for, what's going to be the easiest. Okay, so when we look at these two equations, we want to eliminate one of the variables. But if I do nothing right now, let's just add these together right now. I'm going to get 7x plus 3y equals 42, and notice that no variable has eliminated, right? So before I eliminate, I actually have to make sure that it's going to eliminate. I got to get some of the variables to have the same numbers in front. So let's do this. 10 is a multiple of both 2 and 5, right? So I can get this to be a 10 or a negative 10, and I can get this to be a positive 10. So what I'm going to do is I'm going to multiply both equations. I'm going to multiply the top equation, everything in the top equation, by 5. Okay, so that will give me a 15x minus 10y equals negative 25. So every piece of that top equation got multiplied by 5. Okay, and you can do that. So basically what I'm doing, I'm just trying to keep it clean, but basically what I'm doing is I'm multiplying by 5 here. Okay, and then distributing this 5. On the bottom equation, I'm going to do something similar, except I'm going to multiply everything by 2. Okay, so 2 times 4x is 8x, and 2 times 5y is 10y, and 2 times 47 is going to be 94. Okay, now why did I do that? Okay, let's check it out. Now I have negative 10y and positive 10y. Right, so I forced this thing to actually eliminate the way I wanted it to. Okay, now I can add them together and something's actually going to happen. So 15x plus 8x, that's going to give me a 23x. Okay, the y's cancel, which is great. That's exactly what I wanted to have happen. Okay, and then over here, we got negative 25 and 94. So when we put that together, that's going to be, let's see, I don't know if I can do that in my head. I think it's going to be 69, but let me just double check that. 94. Yeah, okay. All right, cool. Okay, so now I have this equation. Let's divide both sides by 23. Okay, and then I get x is equal to 3. 69 divided by 23 would be 3. So this one actually did have a solution. Okay, let's go ahead and find the rest of it. So we have the x part, now we just need the y part. So I need to take this number and I need to plug it in here or here, or here or here, it doesn't matter, one of these 4 equations to find out what the y is. Let's just do the first one because it's the easiest one.
Mr. Meredith, please come to the front. Thank you.
So I'm just rewriting the first equation again, okay, but I'm replacing x with what I know it is now. That means that 9 minus 2y is equal to negative 5. And I just keep going to solve for y. So negative 2y equals negative 14. Okay, divide both sides by negative 2, and we get y equals 7. Okay. So this equation actually has a solution, which is 3, 7. Okay, so we saw a situation where we got no solution. We have a situation where we got one solution, right, and we actually found out what it is. Let's try a situation where we're going to get no solutions, okay? So this is, I kind of went in a funky order here, sorry about that. But let's just, let's pick another one here, okay? Let's do 11 will be a good one. Actually, let me do one that's a little bit harder than that. Let's do 13. All right, so 4x plus 4y equals negative 8, and negative 2x minus 2y equals 4. Okay, so I got to do some elimination, right? I got to get some variables to eliminate. If I try to add these equations together the way they are, I'm going to get 2x plus 2y equals negative 4, which doesn't really help me because I haven't gotten rid of a variable yet, right? The whole goal of elimination is to actually eliminate something. It's to get one of the variables to go away. So I need to multiply one of the equations to make that happen. Well, this is a 4, and I could get this to be a negative 4 pretty easily, so let's try that. Okay, let's try to multiply the bottom equation by 2. Okay, so I'm going to multiply everything on the bottom by 2. So that equation is now going to become negative 4x minus 4y equals 8. So 2 times negative 2 is negative 4. 2 times negative 2 is negative 4. Of course, I have the x and y in there. And then 4 times 2 is 8. Okay, so this is my new equation. Let me rewrite them. Here's the top one. Here's the bottom one. Okay, and now let's try to do the elimination. Let's see what happens. Okay, 4x and negative 4x, when I put those together, that's 0, right? So I cross that out. Okay, 4y and negative 4y, that cancels out too. Now, if everything cancels out, we need some kind of a placeholder. So I'm going to put a 0 there. Okay, and then we have negative 8 and 8. Those cancel as well, right? So if everything on the side cancels, you got to put a 0 down. And now I get this thing, 0 equals 0. And we call this an identity. Okay, an identity is an equation that's always true, some number equal to itself. Okay, and so when we get an identity, we say there's infinite, let's actually write out the words. In your book, it'll say infinitely many solutions. Okay, so again, let's go over the 3 scenarios really quick. Okay, we could get no solution. Okay, how do we know? Because somewhere along the line we get a contradiction. We get some statement that's not true and it doesn't have any variables in it. All the variables go away, we end up with an untrue statement. That's called a contradiction, and so our answer is no solution. Okay, the other option is that we actually get a solution, like it actually works. Okay, so I wanted to give you an example where that happens, and I picked like a hard one where you have to actually multiply both equations. Okay, and then the other option here is that you try to solve an equation and you get what's called an identity. And if that happens, then your answer is infinitely many solutions. Okay, so there's 3 different options, 3 different scenarios that you could potentially get. Okay, all right, so that's 3 from that section. You guys can kind of do the rest there. But let's take a look at the next section. Okay, the next section is right here. So in this section it says use only the slopes and y-intercepts of the graphs of the equations to determine whether the system of linear equations has one solution, no solution, or infinitely many solutions. Okay. Now let's go back to one of the problems we talked about just a second ago. Okay, number 10. This was the first one we did. Now, if you notice, these equations here are both in slope-intercept form. We talked about that already. Okay. When you have slope-intercept form, you can really easily see the slope, and you can compare the slopes of the two equations. You can also see the y-intercepts. So if you have the same slope but different y-intercepts, that means the lines are parallel. So without even like trying to solve it, you can tell that there's going to be no solution to this system just because of the slopes. Okay, so that's what it's trying to get you to see here. It's trying to get you to practice like using slope-intercept form to be able to see, kind of predict if your system's going to have a solution or not. Okay, so let's take a look at number 17, and we'll do 22 together as well. So I'll give you a couple examples from that section if you need it. Okay, so 17, notice the first one starts off in slope-intercept form. That's great. The second one, however, is not in slope-intercept form. So when you look at this second equation, you can't really see the slope. You can't really see if it's a 7 yet. Okay, so I'm going to show you how to solve the equation, second equation, for y. In other words, put it into slope-intercept form. So I'm going to call this guy equation 1 and this guy equation 2. Okay, equation 1's fine. What we want to do is we want to take equation 2 and we want to convert to this form. Okay, we want to get y by itself. Okay, so the first thing we're going to do here is we're going to get rid of this chunk. I'm going to add 21x here. I'm going to add 21x here. Okay? All right, on the left it's gone. So on the left-hand side, I just have a 3y left over. Okay, now here's where it gets tricky. A lot of times we want to put these together. We're like, oh, 39 and 21, that's 60, right? Well, this one has an x, and this one doesn't have an x. So they're actually not like terms, meaning I can't really combine them. I can't put them together the way I want to, because this one doesn't have an x. So I can't really combine them. So if this is 39 plus 21x, right? Nothing I can really do there. However, I can reorder those. I can like rearrange them if I want to, and that's fine. So I'm going to do that. Usually I don't write this step, but we want the x's first, right? Because we want y equals mx plus b, so we want the x's first. So when we actually put these together, we can't combine them, but we're going to put the x first. Okay, we're almost there. Okay, we just want to get y by itself. So the next step is to divide both sides by 3. Okay, because we want to get rid of this 3 here. This is 3 times y. The inverse of multiply by 3 is divide by 3. Okay, so we get y equals this stuff. Now, we're not quite in slope-intercept form yet. So what we need to do is we need to actually, this is almost like a distribution. We have these two different pieces over a common denominator. And so what happens is actually each piece gets divided by that number there. Okay, so we split the fraction up. Okay, now we simplify. 21 over 3, well, 3 goes into both of those. 3 goes into 21 7 times, and 3 goes into 3 once, so we got 7 over 1, or just 7. Okay, 39 divided by 3 is 13, or 3 goes into both of these. 3 goes into 39 13 times, and it goes into 3 once. So 13 over 1, or 13. Okay, now this is equation 2, remember? So all we did was just rearrange it. Now that we have it in slope-intercept form, let's compare these two. Okay, what do you notice? They have the same y-intercept, or sorry, excuse me, they have the same slope, but they also have the same y-intercept, right? That means that these are actually the same line. These are the same equation. So if we have the same slope and the same y-intercept, that means that these two lines are actually not different lines, they're like the same line. Okay, so what we have is we have this situation. We have two different equations that are actually the same equation, right? The lines are the same. So we have infinitely many solutions here. Now we did that a different method. We actually just converted one from into slope-intercept form. So same slope, same y-intercept. That means there's infinitely many solutions. Okay? All right. Now that skill is a little bit tricky, so let's try to do that again. Okay, let's take a look at 22. All right, so 22, we got 2x minus 2y equals 16, and then we got 3x minus 6y equals 30. Okay, now you could try to solve this, right? You could actually try to do like elimination here. You could, multiply the top one by -3 or whatever, but that's not actually what it's asking you to do. It's asking you to use slopes and y-intercepts, right? So we're just going to try to predict if there is a solution just based on the slopes and the y-intercepts. But since both of these are in standard form, we want to convert them to slope-intercept form. Then we can actually look at the slopes, right, and see what's going on. Okay. Now again, we could solve this with elimination. We could totally do that. But we want to maybe kind of just predict whether they have the same slope or not to see if there's actually going to be a solution here. All right, so let's start by transferring these, and this is good practice to change something from standard form to slope-intercept form. It's good practice anyway. So let's start with equation 1, right? Here's equation 1, just this guy. All right, so we're going to subtract 2x from both sides. Okay, on the left, that's going to leave me a negative 2y, excuse me. Now, remember, these are not like terms, okay? You can't actually put them together, but we can put them in whatever order we want. So this is 16 minus 2x or negative 2x plus 16. We don't want to actually combine the numbers and get a 14 because this one doesn't have an x. Okay, so we just kind of leave it. Okay, the next step is we want to get that y by itself, so we need to divide both sides by -2. Okay, now another way to think of this is just divide every single term by 2. So there's one term over here, there's 2 terms over here. Let's just divide every little piece by -2, right? The terms are separated by the equals and the plus. Okay, so the same thing we did up here, we're just kind of saving some steps, right? We take this and both of them went over 3. Okay, same thing over here. We just divide both of these guys by -2. Okay, so -2 over -2, that cancels and gives us just a 1y, or just y. Okay, -2 over 2 here is also a 1, right? So -2 divided by -2 is 1, but we have 1x. Okay, and then we have 16 divided by -2, which would be -8. Okay, so this is equation 1 in slope-intercept form, right? It has a slope of 1, like an invisible 1 here, and it has a y-intercept of -8. Okay, let's look at equation 2. Okay, that's equation 2. Again, we want to do the same thing. We want to get y by itself. So let's subtract 3x from both sides. Okay, that goes away. That's what we wanted. That leaves us with just a -6y on the left. On the right-hand side, we have 30 minus 3x. Again, they're not like terms. We can't combine them. So 30 minus 3x is just 30 minus 3x. But we can rewrite it. 30 minus 3x is the same as -3x plus 30. Okay? Now we divide both sides by -6. But when we divide, both sides, really what we're going to have to do is we're going to have to divide all 3 terms by -6. Okay, so every little piece here gets divided by -6. All right, -6 over -6 is just 1, so that's just a 1y. Okay, we got a -3 and a -6. So if there's 2 negatives here, negative divided by negative, they're going to cancel. We're going to get a positive number. And then 3 goes into both 3 and 6. 3 goes into 3 once, and 3 goes into 6 twice. So the negatives cancel. We get a positive 1/2 x. Okay, now we have over here a positive divided by a negative, which is going to give us a negative number. And 30 over 6 is 5 over 1, or 30 divided by 6 is 5. Okay, so let's compare them. They have different slopes, so these guys will actually intersect. So different slopes. Okay, if you have different slopes, then you're going to have one solution. They're actually going to intersect and you're going to get a solution. So we didn't actually find out what the solution was because they didn't ask us to. They just asked us to determine if it has one solution. And so we did. We determined it had one solution. Okay, so let's do one more scenario here. We won't do a problem, but we'll just kind of talk about it. Okay. Now these guys came out to be the same equation, right? So the same equation means there's infinitely many solutions, right? The same slope and the same y-intercept. Okay, these guys had different slopes, okay, completely different slopes. If they have different slopes, they're going to have to, the lines are going to have to cross, and you're going to get one solution. Okay, the other scenario that you could potentially get is no solution. Okay, so let me show you how that would work. If I were solving my equations, and let's say equation 1 came out to be y equals 3x plus 1, and equation 2 came out to be y equals 3x minus 4. Okay, in this scenario, notice the slopes are the same, but the y-intercepts are different. Okay, same slope, different y-intercept. These are parallel lines. Okay, so if you get same slope, but a different y-intercept, then you're going to get parallel lines, which means you're going to have no solution. Okay, so one of those problems in that set will probably have no solution. Okay, so let's go through that kind of one more time here, just to kind of talk about what we're doing. Okay, in problems 9 through 16, you're actually going to try to solve them, right? Use elimination or use substitution to try to solve the system. You may get a contradiction, in which case you'll say no solution, or you may get an identity, in which case you'll say infinitely many solutions. Okay, you also might just get a regular solution, and that could work too. And we went through one of each of those. Okay, over here, this is the problems that we're just looking at. Okay, you're not going to solve them, you're actually going to convert them into slope-intercept form. Make sure they're all in slope-intercept form. Okay, once you have them in slope-intercept form, you can compare the slope and the y-intercept, which is what it's asking you to do, to see if there's going to be one solution, infinitely many, or no solution. So if the equations are the same, the slope and the y-intercept, you have infinitely many solutions. If the slopes are different, you have one solution. If the slopes are the same, but the y-intercepts are different, then you're going to have no solution. And we kind of talked about those three scenarios. Okay, next up you have a couple, find the error problems. So take a look at those and read through them and kind of determine what's going on here and why there's an issue. And then you think you have 29 and 30. Okay, so 29 is you're just going to kind of like do some writing, write a sentence or two about what you think about this system of equations that have different slopes. And then you're going to kind of take a look at this graph here and answer some questions about this graph, kind of reading this graph for practice. Okay, so I'll leave you to that, but that should help you get started, and I'll see you guys back in class soon. Thanks.